In this video, we're going to talk about dividing polynomials. So there's two methods that we're going to talk about with dividing polynomials. One of them is long division, the other is synthetic division. They both do exactly what we want. We're going to start by just reviewing how we would use long division to divide a number. So let's look at this. If we have 360 and we divide that by 5, if we're going to use a long division, we put this first number in our little division house, I call it, and we put the second number on the outside. Now we ask ourselves, moving left to right on the inside, how many times does 5 go into 360? Well, first we ask ourselves, can 5 go into 3? Well, it can't. So as a placeholder, I like to still put a 0 there. Then we ask ourselves, does 5 go into 36? It does, 7 times. So we're going to go 7 times 5 now, which is 35, and we write that underneath the 36. We subtract that from 36, and we get a 1. There's still more numbers left, so we have to bring the next number down. We ask ourselves now, how many times does 5 go into 10? Well, 5 goes into 10 2 times, so we go 2 times 5, which is 10. We subtract them and have a remainder of 0. Let's do one more. We're going to take 366 divided by 11. So let's set up our long division. 366 divided by 11. 11 does not go into 3, but it does go into 36 3 times. 11 times 3 is 33. When we subtract that from 36, we have a 3 left, and we bring down the next number. We already know 11 goes into 36 3 times, so we're going to subtract 33 and have 3 left over. But instead of continuing, remember, we can write this 3, which is a remainder, two ways. We can write this as 33 remainder 3, or, this is the way we're going to use it when dividing polynomials, we can write this as 33 and 3 over 11. So if we're going to use a long division with polynomials, this is how we would write a remainder. So let's look at how we would use a long division to divide polynomials. So our first example, we're going to take x squared minus 4x minus 12, and we're going to divide that by x minus 6. So this is how we do long division with polynomials. We're going to take that first part and put it in our little polynomial long division box. So we have x squared minus 4x minus 12, and we're going to put x minus 6 on the outside. We are only, when we are asking ourselves how much does x minus 6 go into the other expression, we are only going to worry about the x. The minus 6 will take care of as we move along. So we're going to ask ourselves, how many times does x go into x squared? One way we can figure that out is if we take the x squared term and put it over x. And remember, that x is an x to the first. When we are dividing exponential expressions with the same base, we subtract the powers, so we're going to have just an x. So that means x goes into x squared x times, so we're going to write that above the x term. Then, this is where the minus 6 is going to come in. We're going to go x times x squared, x times x, and then x times minus 6. X times x is x squared. X times minus 6 is minus 6x. We are going to then take and subtract that entire expression. We're going to go x squared minus x squared, which zeroes itself out. We're going to go negative 4 minus, negative 4x minus negative 6x, which means we're going to add 6x to negative 4x. We're going to get 2x, and then we bring the next term down, minus 12. So now, again, we are going to ask ourselves, how many times does this x from the x minus 6 go into 2x? So if we take 2x and put that over x, we're going to be left with just a 2. So we put a plus 2 as our quotient. Now we go, the plus 2 times x gives us a 2x. And we go plus 2 times negative 6, we get minus 12. And we subtract the entire expression. When we go 2x minus 2x, that zeroes out. Negative 12 minus negative 12 is like negative 12 plus 12. Also zeroes out. We have no remainder. So our answer is going to be the x plus 2 that we got right above the division. So that was an example that had no remainder. Let's check out an example that does have a remainder. So example 2, we're going to take x to the third plus 2x squared minus 4x minus 12, and we're going to divide that by x plus 3. So we're going to start by putting x to the third plus 2x squared minus 4x minus 12 in our little division box, and then x plus 3 outside. Now we ask ourselves, how many times does x, just this first x, go into x to the third? So if we go x to the third over x, we're going to be left with an x squared. That is going to go over our term that has an x squared. X squared times x. Remember, now we take and multiply this by everything in what we're dividing by. So x squared times x is x to the third. X squared times 3 gives us plus 3x squared, and we subtract that entire expression. X cubed minus x cubed is gone. 2x squared minus 3x squared gives us a negative 1x squared, but we just have to write negative x squared. And then we bring down the minus 4x. Now we ask ourselves, if we have negative x squared, how many times does x go into that? Well, we're going to have a negative x. So we write minus x. And again, we multiply that by x plus 3. Negative x times x is negative x squared. Negative x times 3 is minus 3x. And we subtract the entire expression. The first term, we're always going to be getting rid of that. When we go negative 4x minus negative 3x, we're going to get a negative x. And we bring down the minus 12. So now we ask ourselves, if we have x or negative x, how many times does x go into that? Well, the answer is negative 1 times. So we write minus 1. We multiply x plus 3 by minus 1. We get negative x minus 3. I've run out of space to show you my work, so I'm going to write that over here. The negative x minus negative x is gone. Negative 12 minus negative 3 is going to give us negative 9. So that means we have a remainder. Now, to write our answer with this remainder, what we're going to do is we're going to put a plus sign at the end of the answer we're developing, and we're going to make a fraction. We're going to put negative 9 as the numerator. Whatever our remainder is, that's our numerator. And then whatever we were dividing by in this problem, in this case it's x plus 3, that becomes our denominator. So our answer is going to be x squared minus x minus 1 plus negative 9 over x plus 3. That's the answer to example 2. So there is one other type of division we can use when dealing with dividing polynomials. It's called synthetic division. And it only works when we are dividing by a linear binomial. So for example, in fact, we're just going to move into example 3. And we're going to call this using synthetic division. If we have 2x cubed plus 8x squared minus 3x minus 12, and we are asked to divide that by x plus 4, synthetic division has a very interesting way to do it. It's going to look very different from long division. We are going to create an upside down box, you could think of it. And we are going to take the coefficients of the first thing in our division problem. So remember, the coefficients are the numbers in front of the variables. And then we also write the constant at the end. So we're going to just take and write 2, 8, negative 3, and negative 12. Now on the outside, right here, we're going to take and put whatever number would make the divisor, the second part of our division, equal 0. So if we have x plus 4, let's just set that equal to 0 and solve it for x. So we subtract 4, which means x would have to be negative 4. So our number that's going to go outside this box is going to be a negative 4. Now this process is going to seem kind of weird, but it works out really nicely. We're going to bring down this first constant, and we're just going to write that there. It's going to be a 2. Then what we're going to do is take this blue negative 4 and the red 2. We're going to go negative 4 times 2, and we're going to put it right under the 8. Negative 4 times 2, that's just negative 8. Then we're going to add, going down. 8 plus negative 8 is 0. Then we're going to do the same process. We're going to go negative 4 times 0, which is going to just give us a 0. We add going down. Negative 3 plus 0 is negative 3. We keep repeating the process. We're going to go negative 4 times negative 3. Negative 4 times negative 3 is positive 12. Adding down, negative 12 plus 12 is 0. Now, the question is, what do we do with these numbers we just got? Well, they're part of our answer. So, we're going to write that. This very first number, the 2, that's the coefficient of our first term. So it's going to be 2x, and the power is going to be reduced 1 from the original problem. So we're going to have 2x squared plus, and then we're just going to keep reducing the power by 1 as we go down. 0x to the 1 minus, because that 3 is negative, 3x to the 0. Once we get to a 0 power, remember anything to the 0 is 1, so we don't even have to write that. And then this last number is any remainder we have. So I'm just going to clean up my answer because 0 times x to the first, that's just going to be 0 and it's going to go away. So our final answer is going to be 2x squared minus 3. I think we should look at least one more example like this. So I want to take x squared. This is our fourth example, excuse me. We're going to take x squared minus 9x minus 10, and we're going to divide that by x plus 1. So we make our little box. The number in front of x squared is 1, then negative 9, and minus 10. The number that's going to make x plus 1 equals 0 is going to be negative 1. So we write that on the outside. We bring down this first number, and then we multiply it by negative 1. 1 times negative 1 is negative 1, and we add going down. Negative 9 plus negative 1 is negative 10. We multiply that again by negative 1, and we get 10. Negative 10 plus 10 is 0. So our answer is going to end up being 1 x to the first minus 10, which we can simply write as just x minus 10. Okay, that's going to wrap up our lesson on dividing polynomials. You can use either long division or synthetic division. It is your choice. Any of the problems I'm going to give you are not going to have any remainders to deal with, but we're going to play around with them and see how this works in class.